Lesson 5.7, we're going to use the fundamental theorem of algebra. Basically, the theorem states that you will have as many roots as the highest degree. For instance, a quadratic is a polynomial with a degree of 2, so it has 2 roots. A quartic would have 4 roots. Here you can see we have 2 intersections. What's important is that the roots include complex values. That is why we sometimes see a quadratic that doesn't necessarily intersect the x-axis. And we've seen them look something like this. Well, it's kind of wide, but anyway, something like that. Also, what's important is that complex roots come in pairs. So a polynomial with a degree of 3 might have 3 real roots, or because they come in pairs, 1 real root and 2 non-real. While a 4th degree polynomial might have 2 real, 2 non-real. All 4 might be real, so you'll have 4 intersections at the x-axis, or 4 non-real, so it never intersects the x-axis. So note the difference between odd degree versus even. Let's look at a pretty basic polynomial. So we can see that the degree is 2, so we should end up with 2 solutions. We're going to factor out the common monomial, which was 3, and when I got to x squared minus 6x plus 8, I could factor it one more time and get x minus 4, x minus 2. So I can see that my roots are going to be 4 and 2, and I could determine those by using the zero product property. So again, I ended up with 2 solutions, and my highest degree was 2. Now we're going to find the zeros of this polynomial, and we can see that the degree is 5, so we should get 5 solutions. We might find the rational zeros and use synthetic division. However, when I looked at this a little bit more closely, I thought, I wonder if I can begin factoring by using factor by grouping. So that's what we're going to try. Out of the first set of parentheses, I will take out an x cubed. So I'm left with x squared minus 4. And the second set of parentheses, I'm just going to factor out a 1. We have to take something out. So x squared minus 4. We'll take our lookalikes. Again, not a mathematical term. What we factored out. And now look at these 2 binomials and think, what else can we do? The first parenthesis is a cube, so we'll find the cube root, x plus 1. We square that, so it's x squared. We square the 1, which is just 1. We multiply 1 and x, so we get x, and then it's going to be a minus sign. We need to create opposites so that if we distribute the x plus 1 into this trinomial, we would get back to a binomial. And then the x squared minus 4 is the difference between squares, so x plus 2, x minus 2. At this point, I can see that the x plus 1 would give me a solution of negative 1. X plus 2 is negative 2. The x minus 2 would be a positive 2. So I need to deal with the trinomial. So let's use the quadratic formula on this one. Our quadratic formula states negative b plus or minus b squared minus 4ac under the radical all over 2a. And I labeled the parts of our trinomial as a, b, and c and included them in the formula. So we end up getting 1 plus or minus 1 minus 4 all over 2, 1 plus or minus a negative 3 under the radical sign you see over 2. Sorry, it's getting a little bit crowded. And we know that when we have a negative under the radical, we can say 1 plus or minus I square root 3 over 2. When we started, we said we would have 5 solutions. We have 1, 2, 3, and it's plus or minus, so we have 2 more solutions down here. So we have a total of 5 solutions. And then at the beginning of the lesson, we also said that it could intersect the x-axis up to 5 times. In this case, you can see I graphed it on the calculator, and we have 1, 2, 3 real solutions, and then our extra 2 imaginary. I'm going to continue this lesson on another video. In the second video, we're going to use zeros to write a polynomial function.